Hello, fellow human beings. This is Robert Roach with the Type 1 Planet podcast, and today I had the pleasure of speaking with Yonas Sanbrink. He's an expert in the field of biosecurity, and his research focuses on the dual-use potential of emerging technologies and how to prevent catastrophic biological risks. He's currently a doctoral researcher at the Nuffield Department of Medicine at the University of Oxford, where he's studying the security aspects of emerging technologies to create and engineer viruses. And he's also working as a Biosecurity Advisor for Google DeepMind. Previously, Jonas was a researcher for the Future of Humanity Institute, where he worked on mitigating risks for emerging technologies and preventing catastrophic biological risks. Now, in this conversation, we attempted to have a nuanced discussion about the risks and benefits of scientific research that utilizes viruses to make scientific discoveries. We talked about the misconceptions and the generalizations that are commonly made regarding phrases like gain-of-function research, why that phrase has become a buzzword, and we discussed the phrases that are more accurately describing the situation at hand, phrases like the enhancement of potential pandemic pathogens. We talked about the proliferation of research that utilizes viruses and viral genomes and the balance between risks and benefits of those projects. We talked about the delay, detect, and defend methodology for preventing pandemics, with a special attention to Jonas's research related to delay around possibly regulating or enhancing the security around viral genome information. The keywords of this discussion are nuance and education. It is a natural human tendency to look for the boogeyman after a global event like the COVID-19 pandemic. And Jonas reminded me multiple times that these are the kinds of conversations that require patience. They require perspectives from every side and a tendency towards learning rather than just judging. This is likely the beginning of many conversations on this topic as we try to find ways to prevent and survive pandemics as a species. Thank you for joining the Type 1 Planet podcast. Please give us feedback, collaborate with us, talk to us. We are at Type 1 Planet on social media, and you can visit our website, type1planet.net. All right, hello and welcome to the Type 1 Planet podcast. This is Robert Roach, and today I have with me Yonas Sanbrink. He's an expert in the field of biosecurity, and his research focuses on how to prevent catastrophic biological risks. He's a doctoral researcher at the Nuffield Department of Medicine at University of Oxford, and he's studying security aspects of emerging technologies that create and engineer viruses. And he's also doing some work as the Biosecurity Advisor for Google DeepMind, which we can't go into because of NDA requirements. But Jonas, it is a pleasure having you on today. Thank you for joining me.
Robert, thank you for having me. I'm very excited to be here and talk a bit about biosecurity.
All right. So you've actually described your work as being about the conflict between security and transparency in scientific research. For people who don't understand this relationship, what is the conflict that we face as a species?
So obviously, science and technology have brought great boons for humanity. So our medical advances have led to us being healthier, living longer, being able to treat diseases. Our research into pathogens enables us to develop vaccines and preempt, hopefully, future pandemics and infectious disease instances. And at the same time, however, many of these technologies, and I mean, obviously you can just look towards kind of nuclear technology as the most extreme example, but also other technologies in the science, in the life sciences and biotechnology feature risk. And those risks could come, for instance, in the form of if you learn how to create a pathogen and what makes a pathogen transmissible and able to cause disease, you could then use that knowledge to also create a pathogen for ill and to cause harm, to potentially deliberately cause a pandemic. And that is, a fundamental of a lot of the life sciences research that currently is conducted. And it is actually is only a small set of research that actually features a lot of this risk in the most pronounced forms. And I think that is the set of research that I try to study and that I try to understand, and really how, in that instance, how do you weigh off benefits and risks? How can you create policies that ensure that we get those benefits, that we do the research that we really need to do to advance our civilization, but that we also prevent catastrophic risks that are emerging from that work.
So there's a phrase that many people are going to be familiar with, which is gain of function research. They're going to be hearing it in the news and in podcasts and people arguing about it. And I was wondering, this is, I think, probably the most publicly available phrase that's related to this kind of work that you're doing. What is gain of function research, and is there something like a steelman argument for its existence? It sounds dangerous, but why does it exist?
The gain of function term is really interesting because it is quite controversial in the sense that it, on the surface, captures a lot more than what we're actually concerned about. Gain of function is just a very basic step, experimental step of something acquiring a new function or enhancing something a little. And it has mostly been used in the terms of these risks to refer to gain of function research of concern, and gain of function research specifically on a small number of pathogens that could result in the creation of a potential pandemic pathogen. So it is really only a small fraction of all theoretical gain of function research that kind of policy discussions around gain of function research are focused on. And actually the term that is used a lot more these days is enhancement of potential pandemic pathogens. And that's used, for instance, in the US policy oversight about this research. So what is this research? After having explained a bit the sensitivity of this term, so enhancement of potential pandemic pathogen research is research on viruses that might pose a potential pandemic or health emergency in the future. That can, for instance, be an influenza virus or a coronavirus. And you pick up some virus in the more archetypal form. You pick up a virus in nature that might in the future spill over into humans. And what you're trying to do in the lab is you're trying to understand what mutations would that virus need to acquire to be able to make that jump into humans. And then if you do those experiments and then you find out what those mutations are, then you can use those to track how close is a virus that is currently circulating in animals to jumping into humans. And potentially using those mutations, you can then also also develop vaccines and inform kind of other countermeasure developments. And I think one concrete example that people are saying is in 2012, kind of the origin of some of these debates were the controversial studies on H5N1 avian influenza virus. And researchers were doing work to enhance their transmissibility. But now we have actually H5N1 circulating in many bird species. And because of that work, you could argue that we have some sense of how far the virus is to spilling over into humans. And that enables us to appropriately respond with regards to our policy and our interventions.
It's so it's interesting. So you're actually making a clarifying definition between gain of function, which has it's basically a methodology, isn't it? And then versus the thing that everyone actually is concerned about and referring to, which is the viral research, right? It's the pathogen research.
It is gain of function research that could actually result in a potential pandemic virus.
Got it. And is that what you're calling? Use a phrase called transfer risks?
No, I think I would not call this transfer risks. So I would call these.
Okay.
I would call this research with intrinsic risks. In a sense, there is.
Okay.
When you do this activity, you do it to try to understand the threat, the potential for the future pandemic pathogen, and therefore the information, the more solid information you want, the greater, and that the most solid form being potentially creating these viruses in the lab to identify what mutations would make them transmissible, the more risk you produce, because then you have risk of accidents and the thing getting out of the lab, or you have risk of misuse if you publish the genome online and then other people might recreate it. And so it directly, kind of the threat assessment means that you automatically produce, at least from a dual use perspective, from a misuse perspective, you produce, information that could be misused.
Okay. And so there's entire industries then. I mean, research industries that are using viruses as tools for research. Is that correct? Can you, like, for example, it doesn't need to be related to research around pathogens and, epidemic level viruses. You can be using viruses as a tool to be approaching some other form of human health related research. But the tools and the strategies and the knowledge that is accrued during that research can be used for, or maybe misused in some way to create a pandemic level virus. Is that correct? From your writing, I've been trying to figure this one out.
Yeah, and I think there we move a bit into a different space. So people are doing, for public health purposes, they're doing research on viruses to characterize kind of future emerging risks. So that's the stuff that we've talked about so far. And that involves quite a lot of other research areas as well that don't involve the enhancement of potential pandemic pathogens. But then also, as synthetic biology advances and as the ability to understand and to engineer viruses advances, people have realized that these viruses are a very useful tool. You can do a lot of kind of medical interventions with them and a lot of experimental kind of setups draw on viruses. So you can not only use viruses as vaccines, which has been done for a very long time, but you can also modify viruses to deliver genetic material into cells. And that is, for instance, being done for gene therapy. So gene therapy involves using a relatively benign virus, most frequently adeno-associated virus, AAV, and kind of modifying it in a way that makes it even less concerning and kind of not transmissible between humans, even though that's actually not that much of a concern for AAV anyways, because it requires adenovirus to be present at the same time to actually be able to then replicate and transmit to other humans. However, they modify these viruses and they basically insert a genetic sequence, for instance, for the target gene therapy kind of product, so the gene that the person is missing, and they insert it into this virus, and then this virus is injected into someone and used to deliver the genetic material that is missing to the tissue where it is missing. And thereby, the idea is that this then cures people of the genetic disease. And these therapies are very much needed because there are many, many people with previously untreatable diseases that could be treated with these. However, at the same time, you can imagine, as we learn how to engineer these viral vectors, these viral delivery mechanisms to become ever more sophisticated, to target specific cells, to evade the immune system, to get actually as an efficient therapeutic into the human, as you develop cancer therapies, where you develop viruses targeted to cause damage in the human body. As you do all of that, you also generate knowledge that can be misused. And the fear is that as kind of, the ability to create such kind of highly sophisticated engineered viruses becomes more widespread and more people can do that, the misuse risk goes up. And I think, to put all of that in perspective, I think this is kind of a bit kind of still out there with regard to how large is the risk compared to kind of all of these other direct studies on viruses. And I think while those feature also significant safety risks and risks for accidents to happen, that obviously that could result in a pandemic. That is not necessarily the case for these viral engineering efforts for gene therapy and cancer therapy, because often they explicitly frequently don't involve pathogenic viruses and viruses that could that would, if they got out of the lab, cause a pandemic. I mean, those viruses are not being used there. So it really is a discussion around misuse potential and dual use risk. And I think it's still probably an order of magnitude kind of difference in riskiness. But what I've been doing in some of my work is I'm hoping to start some of that conversation in which we conceptualize risk in a broader way and think about not just kind of the highest instances of risk, but also think more broadly, if as a society we would want to prioritize technologies that give us the greatest benefits, then I think also we need to always think about what are the risks and then proportionally allocate resources and research efforts.
Mm-hmm. So you're talking about, as this technology advances, as it becomes more ubiquitous, it's the proliferation of the capability, either accidentally or malevolently perhaps, to create pandemic level viruses. And previously, our governments and our scientific institutions, they didn't see the misuse concerns or the risks when this industry was building up. Is that right?
Yes, I would say that is.
And feel free to totally correct me, because I'm trying to understand as a layman.
So I think that
it's helpful.
I think it's. I think generally in recent years, I think there's been around the potential pandemic pathogen research discussion that we talked about earlier. I think there's been a lot of focus on the safety risks of that. And whilst there was, I think in the early 2000s, quite a bit of discussion around security and misuse potential, I think over the past decade, as kind of terrorism has gotten, as kind of the post 9/11 kind of focus on terrorism has kind of worn off, I think people have become slightly less focused on seeing the misuse potential in everything. And so I think there has been a lesser evaluation and consideration of the risks around these newer technologies. And I think we need to start having these conversations and awareness building also in these new sectors of biotechnology developers that are increasingly driving processes here. And I think that is in particular also the private industry.
Okay. So let's talk about some of the initiatives and some of the research that you've been working on to potentially help our situation and make it better and design a better system. And one of the phrases that I've heard you use is delay, detect, and defend. And basically kind of breaking up the initiatives or even the educational aspect of all this and the research into those three buckets. And, why is it useful to do this? And for example, what does delay mean versus detect versus defend?
Yeah, so this concept of delay, detect, defend was kind of put out there by Kevin Esveld, and he wrote a report on this topic. And I think it's an interesting conceptualization of how you might think about kind of the different interventions to get ahead of kind of misuse of biotechnology and kind of this challenge that we're facing, that biotechnology is becoming a lot more accessible and powerful, and therefore the misuse potential might be increasing. So the delay portion really thinks about, okay, clearly we're not yet ready, we're not able to stop a pandemic in its tracks, as we've seen with COVID-19. I think our defenses are strongly lacking. So in the absence of that, we need to think about how can we prevent misuse, and how can we make sure that the people that might be interested in misuse, which is probably only a very small number, hopefully, won't be able to kind of use this technology as the most accessible means and most likely means to do harm. And also, how can we ensure that state actors aren't interested in developing biological weapons, for instance? And then around the kind of detect and defend side of things. So I think that really gets then to the vision of the future in which we are able to robustly stop pandemics and counter pandemics, and where we can kind of get towards that robust state of defense, I think then really we need detection. So we need to be able to know when something is starting to circulate, and we need to be able to pick it up and respond fast, because in its tracks, as early as if you detect it earlier, it's a lot easier to spread, because it spread is exponential usually, and therefore if you get there in early, then it's a much easier task to contain something. And then defend, I think that gets to that question of, okay, if you've detected something, what do you do? Kind of what interventions do you have at your fingertips to then put in place to stop something? And I think that, a classic example is obviously vaccines, but then I think we're also in particular interested in pathogen agnostic measures. So measures that might be effective against whatever pathogen that is being thrown at us. And I think things like here will be against any respiratory pathogen, probably masks and personal protective equipment will be very effective. And there are other measures, kind of like physical disinfection methods. Kind of you can use ventilation to remove pathogens in the air. You can use potentially something that's called kind of far UVC, kind of ultra, kind of low wavelength light that isn't able to penetrate the upper layer of the human skin, but can kind of inactivate pathogens. So that is a very experimental idea at the moment, but it could prove useful in the future, and we might be able to outfit indoor spaces where there are gatherings to kind of stop some of that transmission. But I think in this defense class, there's a much broader set. I think antivirals in a broader set, I think, would fit into that as well. Kind of contact tracing methods to be able to kind of stop transmission. So all of that stuff that might be able to actually flatten the curve. And I think that includes also things like lockdowns and thinking about how can you do those in an effective way? How can we in a highly targeted manner respond to early events in a proportional measure that isn't too costly, but then also is able to robustly contain those events.
So it sounds like you've done a lot of work, or much of the work that I've heard you speak about is around the delay aspect of this. Yeah. And one thing that I found fascinating is that the genome of every viral pathogen, and correct me if I'm wrong in this, is actually publicly available. Like if you're setting up a lab, you could access the genome of a viral pathogen. Is that correct?
Yeah. I think basically all of them are.
So they're all available online or whatever the system is, and that there's really no regulation around that. So how is it that we can address that situation? How can we potentially create a new system or use existing infrastructure to regulate genomes of viruses?
Yeah, I think that's the big question is, firstly, do we need to do this? And does this actually meaningfully reduce risk? And I think given the scientific system in that we work, which is very kind of a commitment to open science and openness, and the default assumption that scientific knowledge is public, and we have a lot of the kind of existing genomes already public, I think at this stage, it's probably unrealistic to scrape all of the existing genomes from the internet, and that would probably also do more harm than good. I think what we need to think about is, at the same time, I think we need to appreciate that in the future, we might be discovering pathogens that could be worse than whatever is out there, that could be more easy to create, that could be, credibly able to cause a pandemic in a very highly efficient way. And I think in those specific instances, I think we should be very mindful of the security and openness trade-off that you are facing when you publish something online, and very strongly think about how do you deal with that, and are there certain genetic sequences that you maybe shouldn't be posting publicly. And I think we don't have a perfect kind of solution for this at the moment. I think it will involve a lot of difficult discussions, and I think all we can do is kind of prime the system to hopefully do this.
If you were to theoretically design a system that you felt was the safest, everything that you know regarding the risks in mind, what kind of system would you put together to make it like there's a registration process or a vetting process in terms of when people start using viral genomes for their research? What's the best way from your perspective to do that?
Obviously, all of this isn't very thought out, and I suggest flagging this. And I think that it's a very complicated topic that requires a lot of different considerations. But I'm going to entertain this thought, and I think it makes sense to really know who's doing what. In the sense, I think there are significant security risks of doing research and of doing work, of accessing, of thinking about those agents that could potentially cause global catastrophe. And I think at the very least, for those kind of activities that touch on this global catastrophic risk of a pandemic or a different risk of a similar scale, I think it is worth to think about that researchers and that individuals accessing relevant resources, including genetic material and the genetic information, I think that they should have their kind of an authentication system that is actually kind of quite sophisticated, and that isn't just put in your institution, but actually there is some verification process there that ensures that they have a legitimate reason to access a certain bit of information. And I think that could then not only be focused on kind of genetic sequences, but I think that it's a much wider ecosystem of relevant research materials. I think that includes potential protocols for kind of step-by-step instructions for how to do experiments, for instance, recreating viruses from a genetic sequence. But that can also include tools like computational design tools for new pathogens or for modifying pathogens. And you could kind of have a system in which you potentially have an overarching authentication system that actually is good at tracking who you are when you access these different tools. And that would, I think, provide a baseline of safeguards without saying in advance, we're not doing any of this. And I think you could have then potentially kind of tiered access systems where, a high schooler can maybe access the vast majority of life science research, but maybe not the stuff that involves potentially dangerous viruses or bacteria. And then a university researcher that generally can access more, and then a expert in a specific area that is well accredited, I think, can then access those most dangerous genomes.
It's a really interesting paradox because we focus in this project about democratization of knowledge and, helping scientific knowledge become open access essentially. But there is a safety and a risk concern with democratizing some scientific knowledge. And, that's a really difficult tightrope to walk. How is this something that, what's kind of your perspective on this? I mean, what shouldn't be publicly available? Is that something that you even would be comfortable with answering? And it's okay if you say.
I think the most important thing here is to do a lot of engagement with all parts of the community and stakeholders. And I think that involves talking to the practitioners and the people that are doing the scientific work. I think that involves talking to relevant safety and security expert, that involves talking to ethicists, that involves potentially talking to members of the general public, to the policy system, to across all of these categories, to kind of global stakeholders from different diverse backgrounds and kind of states of origin. And I think I think you need to, an additional factor is kind of equality of access as well. And I think that needs to be considered as well. And I think it's, in the end, I think no individual will come up with kind of the perfect solution. I think it will be a very messy compromise that involves hopefully as many different voices contributing as possible.
Yeah. A messy compromise with a slight net benefit is probably the best we can do, but that'll be interesting to see how it pans out. There was just an article in the New York Times yesterday, or in the opinion section, called "Lab Safety Can Be Improved Without Torpedoing Scientific Process," and there's a lot of interesting stuff being thrown about, because there's a lot of conversations happening. I mean, the U.S. political system is so messed up, and the way that they're trying to even have the conversation is not what you just described, but at least people are talking about it, I guess. There seems like there's a good kind of barrier to entry, or a good place to look at potential projects that are happening. That's when they're making applications to get funding. And is it possible to do a risk assessment before projects even happen? You know, they're asking for funding. They're saying, hey, I want to do this. Are you able to kind of look at the risk benefit assessment of that project before it even gets funded and incorporate that into the process?
I think you're pointing out something really important, and something that makes me optimistic is that still most of the risky research, the research that features risks of a level that are concerning to warrant kind of intervention, that is government funded still. And it's often kind of at the early stages, projects are being done by academics, especially relating to viral research. I think it's probably different relating to AI, etc., and tools and all of that stuff. But it is still a lot of the research that we're talking about when we're talking about virological research, a lot of that is still government funded. And I think that means that government actually sits at the lever and can kind of at the tap and can say, okay, we are only giving money after we have reviewed for risks and we feel comfortable that despite the risks, a certain project features kind of significant enough merits compared to alternatives that we want to pursue it. And that, I think, makes it a lot easier to do, to kind of steer away from too risky areas and towards kind of the most beneficial areas, because actually there is someone sitting at the tap. And I think that makes the challenge a lot easier than, for instance, regarded than for carbon emissions, which is just super distributed, right? And you need to create very kind of sophisticated incentive mechanisms to get people to optimize away from carbon emission. But I think in this case, I think actually government can actually think about its research priorities and think about where might risks come from. And at least with regard to the specific set of virological research, guide that.
So it sounds like a big challenge here is education and helping governments especially, but also people who are entering into these conversations, like someone like me, to better understand what's at stake here, to better understand the technologies, to better understand the mechanisms and the way that the relationships occur between labs and funding, for sources of funding, and with each other and with these technologies. What other resources would you recommend that someone like I, or someone who's maybe working in government, to go check out and so they can start to learn about these sorts of topics to a much greater extent? Where would you send me if I was trying to learn more?
Yeah, it's a very good question. And I think it really depends on what you want to learn more about. I think there are some kind of biosecurity courses that are online that you can kind of subscribe to. I think there are some reading lists if you look up kind of relevant reading on this area. I think you'll find something. I think I'm a bit hesitant to point towards one specific thing, because I think it is a very complicated area, and there are lots of different opinions out there. And I think one should always be very mindful of just listening to one side of the story. And I think there are kind of scientists that are very concerned about kind of not being too heavily regulated and not too much oversight happening. But then there's also a lot of the security experts that obviously, are pushing for something, I think maybe ask about one specific topic, and I can point you towards.
Sure. Well, it's, in the U.S., for example, we have our National Science Advisory Board, and they're proposing a framework to tighten regulations and oversight of pathogens, so there's a more rigorous review and closing loopholes that researchers might actually use to avoid oversight, right? But then on the other side, there's a whole, I think in response to that proposed framework, a whole bunch of researchers and organizations came out saying this is going to severely limit the way that we can do research, and it's going to badly affect the amount of progress that we can make as a scientific body. And it's difficult for someone like me to understand, both sides of the argument, for example. It's difficult to say, okay, right now in the US, we're in this regulatory limbo where there's the government, the White House, the National Institute of Health, the National Security Advisory Board, this huge body of scientists. They're all kind of in this big argument. And the Republicans and the Democrats have figured out how to go on one side and the other because that's what they do. It seems like the stakes are really high, but we don't know, I don't know how to educate myself on this whole conversation as a whole and see it from a perspective that's not heavily biased. So that's it. And I'm not actually asking for you to provide me an answer here, but it's an interesting question that we're trying to figure out how to kind of have this conversation without it being super tainted by culture, which is, for example, gain of function research is a perfect phrase. Super tainted by like culture now, in my opinion, because people have just been using it as a buzzword.
Yeah, and I think you're pointing towards a real need, I think, in the space, and that is discussion between the different sides here. And I think could imagine a podcast format could be very interesting, where you bring in one person that has the one opinion and one person that has the other opinion. And both are interested in making progress, actually, in kind of entangling these issues and then kind of, documenting that. I think one of my favorite pieces actually in this space is called, on gain of function research, is called Gain of Function Research, Time for Real Debate. I think, let me just see. And something according to deadlines. I think it was published almost 10 years ago, but it's
okay. I'll find it and pop it in the show notes.
It's a short article where different kind of virologists and experts that kind of give their own take on the set of experiments, and it's kind of 4 or 5 different people, and they all have kind of somewhat diverging opinions, and it's really interesting to read. It's one of my favorite papers in this space. And I think then otherwise, I think the new National Science Advisory Board for Biosecurity recommendations that the United States, that were put forward to the United States government recently, I think those are a fantastic piece of work. I think a lot of real excellent effort went into really listening to the community, I think, and trying to understand what are actually the things that we need and that are practical and but especially also that are kind of, the next step in getting to that future that we care about, where we only do high-risk research if it is warranted by its benefits to a significant degree. And I think I would recommend looking into those. I think they are, they are definitely a bit in the weeds, but I think they are showcasing very much where existing policies are limited and what the next step might be towards making progress. And then one other piece I want to flag is a relatively long report, but it's one of my, I think one of the most excellent pieces of kind of thorough work on actually misuse risks as they're emerging and it was also done by the by US agency. So I think it was done by the National Academy of Science and Medicine, and it's called Biodefense in the Age of Synthetic Biology. And it is, I think it gives a very vivid rundown, I think, and detailed examination of all the challenges that we're facing, and where specifically kind of risks are coming from. So I can recommend that.
That's great. I'll include that in the show notes as well. Thank you for those recommendations. And something you mentioned is kind of continuing this conversation on a podcast platform. If you had the opportunity to sit down and collaborate or debate or just have the discussion with anyone or an organization, who would that be if you were off the top of your head? And it's all right if you don't have one right now.
Someone who I really highly respect, I think, who especially on the topic of enhancement of potential pandemic pathogens / gain-of-function research is very knowledgeable, and I think has very good and kind of well-balanced standpoints, and really tries to kind of find that middle between benefits and risks, is Michael Imperiali. He's a professor. I don't want to say where because I'll get it wrong, but
all right, no problem.
He's very good, and I really always very highly value his comments on this topic.
Interesting. And you mentioned Kevin Esvelt as well. I think he's at MIT.
So Kevin Esvelt is, I think he covers definitely more one side of the spectrum, which is kind of quite concerned about catastrophic risks. But I think he does have an extreme kind of wealth of knowledge as a biotechnology expert, and actually thinking in a visionary way about these problems. And I can definitely recommend reading the Delay, Detect, Defend report, which I think breaks this challenge that we're facing in a very vivid way, even if I think some of the details are contentious as all of this.
Okay, great. Well, thank you. That's an excellent recommendation as well. Jonas, I have to say thank you so much for your time today. This might just be the beginning of the conversation, and this is a very educational experience for me. So I thank you so much for your patience and your time today.
Thank you. It was a pleasure to be here.
All right, great. Well, talk to you soon, and enjoy the nice weather out in the UK, I guess.
Yeah, thank you.
I hope so. All right.